Hello, good day everyone, especially to our professor, Ma'am Nina Calaka. I am Roxanne Megrafiel-Das, a PhD EM student, and today I'm going to present to you a topic entitled Data Analytics and Data as a Business. Let us start with the definition of data analytics. What is data analytics? Analytics is the use of data, information technology, statistical analysis, qualitative methods, and mathematical or computer-based models to help managers gain improved insights about their business operations and make better and fact-based decisions. That is according to James Evans. Now, business analytics or BI is a subset of data analytics. So, analytics is defined as the scientific process of transforming data into insights for making better decisions. Now, let us have this question. Is data analysis the same with data analytics? Let us find out by first defining what is data analysis. It is the process of examining, transforming, and arranging raw data in a specific way to generate useful information from it. It allows for the evaluation of data through analytical and logical reasoning to lead to some sort of outcome or conclusion in some context. So, in other words, data analysis is a multifaceted process that involves a number of steps, approaches, and diverse techniques. Now let us have this comparison between data analytics versus data analysis using this illustration. As we can see, we have here analysis, which is very concerned with what has happened in the past as it tries to explain the why and the how. On the other hand, we have analytics, something that will describe the future, like exploring the potential future events. The next slide is telling us how different is analysis between analytics with data analysis and data analytics and business analysis and business analytics. So it is telling us that they are not equal. Data analysis is different from data analytics, just as business analysis is different from business analytics. Now let's proceed to classification of data analytics. Based on the phases of workflow and the kind of analysis required, there are four major types of data analytics. First, you have descriptive analytics, then we have diagnostic analytics, predictive analytics, and prescriptive analytics. Let us tackle them one by one. But first, let us explain this classification of data analytics using a graph. This graph is taken from http://governanceanalytics.org, where we have here the context when we tend to look at the level of difficulty. As you can see, we have here descriptive, diagnostic, predictive, and prescriptive. Where in descriptive analytics, we will explain what happened. In diagnostic analytics, we could know why did it happen. And in predictive analytics, what will happen. With prescriptive analytics, as how can we make it happen. So based on this graph, we could say that when there is more difficulty, there is more value. So the more difficult it is, the more valuable it will be. Now, descriptive analytics. Descriptive analytics is the conventional form of business intelligence and data analysis. Seeks to provide a depiction or summary view of facts and figures in an understandable format. This either inform or prepare data for further analysis. Descriptive analysis or statistics can summarize raw data and convert it into a form that can be easily understood by humans. They can describe in detail about an event that has occurred in the past. In other words, it simply tells what is and describe relationships. That's why we also have description decision models. However, you do not tell managers what to do. We have here an example. A common example of descriptive analytics are companies' report that simply provide historic review like data queries, reports, descriptive statistics, data visualization, and data dashboard. Second type of data analytics is diagnostic. Diagnostic analytics is a form of advanced analytics which examines data or content to answer the question, why did it happen? Diagnostic analytical tools aid an analyst to dig deeper into an issue so that they can arrive at the source of a problem. In a structured business environment, tools for both descriptive and diagnostic analytics go parallel. So we are diagnosing. Suppose we are meeting a doctor for consultation. So he will try to understand why this has happened. So when you look at whether it is a descriptive or diagnostic analytics, the tools, the analytical tools which were used can be the same. Only the purpose could be different. Similarly, the diagnostic analytics also tells us if something has happened. For example, the company is not performing well. That diagnostic abilities will help us identify what was the core reason for that, right? The doctor from the previous example, no, will also identify if somebody got some disease, what was the source of the problem. For further example, we have here, it uses techniques such as data discovery, data mining, and correlations. These tools can also be used for your prescriptive analysis. Please remember that. Now let's proceed to predictive analytics. Predictive analytics helps to forecast trends based on the current events, predicting the probability of an event happening in future, or estimating the accurate time it will happen can all be determined with the help of predictive analytical models. Many different but codependent variables are analyzed to predict a trend in this type of analysis. So risk is associated with the consequences of what actually happens. When you say predicting, no, obviously it says that it is discussing about what will happen in the future, right? So we have also what we call predictive decision models that is often incorporated uncertainty to help managers analyze risk. And when you say risk, no, as what I've told you a while ago, it is something associated with the consequences of what actually will happen. So there may be some independent variables, some dependent variables, sometimes more dependent variables, more than one dependent variables, and how these variables are interrelated. So that kind of study is nothing like a predictive analytics. Now we have here framework. So when you look at this slide, you'll see that with the help of historical data, by using different algorithms, we can come up with a model. Once the model is developed, so we can get some predictions about the past events. Let us have an example. So we have here the set of techniques that use model constructed from past data to predict the future or a certain impact of one variable on another. So we have linear regression, time series analysis and forecasting, and data mining. So these are the techniques for predictive analytics. Now let us have prescriptive analytics. This refers to the set of techniques to indicate the best course of action. It tells what decision to make to optimize the outcome. So this actors with the optimization of the results. No, basically it has the following goals like quality improvements, service enhancements, cost reductions, and increasing productivity. So we have here optimization model as an example, along with simulation and decision analysis. So constraints. Are you familiar with constraints? This refers to limitations or restrictions. In prescriptive decision model, it could help us make decisions, especially for the decision makers, no, to identify the best solution. So these are the tools, those you have mentioned, which could be of great use for the optimization, no, and simulation models, along with data or decision analysis. So all of these are under prescriptive analytics. When they say optimal solution, it refers to the values of the decision variables at the minimum or maximum point. Objective function is the equation that minimizes or maximizes the quantity of interest. So optimization involves finding values of decision variables that minimizes or maximizes something such as cost or profit. Now, we always have this question like, why is it important? Why analytics is important? So we have here two main reasons: the demand for data analytics and the element of data analytics. We have here a graph. Can you see it? Okay. So, you see, the trend is increasing, right? That means people are searching in the Google search engine the word data scientist more number of times. As you have here the legend, that blue indicates data scientist and yellow indicates statistician operations researcher. So we are so concerned here with the search trends. What is the most searched term? No? Is it data scientist or statistician operations researcher? The picture shows Google Trends. This was up to March 1, 2017. See, for example, the blue represents the data scientist, and this orange or yellow represents the statistician or operations researcher. Even YouTube, it has its analytics. It is also business. Are you aware of that? We all know that we can basically earn money in YouTube, and everything is monitored in your analytics. YouTube made it easy for their video creators. No? See, the search count is increasing. That means there is a demand for this particular job, data scientist. Now, please notice this newspaper clipping that I have gathered online from the Times of India. There are so many news coming about data scientists and the future requirement for that job. No? You see, the data scientists, as what the headline says, data scientists earning more than CAs and engineers. The demand for data analytics, for your verification, and for you also to be in love with it and become one. Let us discuss further the demand for data analytics. With companies across industries striving to bring their research and analysis or R&A departments up to speed, the demand for qualified data scientists is rising. India will face a demand-supply gap of 2 million analytics professionals over the next 3 years. Even in the United States, only 40 out of 100 positions for analytics professionals can be filled. So imagine the shortage. That was according to Rituparna Chakraborty, the co-founder and senior VP of Team Lead Services. So this information still is coming from that news clippings that I have shown to you a while ago. So there is an emerging field. So many companies are looking for the qualified data scientists. This newspaper clipping also with companies across industries striving to bring their success through searching for best candidates to be their data analytics. So imagine the demand for that job. Are you now convinced to become one? Now let's discuss elements of data analytics. So we are presented here with 3 circles. So we have here the main elements of data analytics. When we say data analytics, there are different elements. One is statistics. Next one is the business intelligence or information systems. Then modeling and optimization. Then simulation and risk, data mining, our what ifs, and we have here visualizations. We can say you're able to do what if analysis. So if you go with that, that is just one of the elements of data analytics. That is nothing but sensitivity analysis, visualization, data mining, and such. Many times you see what is data analytics. We know about statistics already, right? And made mention about data mining and optimizations from the previous slides. So these are the components of data analytics and how these different domains are interrelated. Next, we will see what kind of skill set is required to become a data analyst. Next, we will see what kind of skill set is required to become a data analyst. Then, we will see the small difference between data analyst and data scientist. They were to work together, these 3. The required requisite skill set. We have mathematical expertise, logical or hacking skills, business and strategy acumen. This will lead to data science. To become a data analyst is the basic fundamental knowledge. The basic fundamental knowledge you need is to have the knowledge of mathematics, the mathematical expertise. So these 3 skills are required for a good data scientist. How to use the data to get more information. So the next skill is business strategy acumen, where you should have the knowledge of the domain and the knowledge of the business, and you must know well the strategy equipment or what strategy to use to make that business boom in the market, along with a lot of competitions. Then we have the knowledge of technology or the hacking skills. It might sound bad, but companies are needing people who are so good in hacking, because somebody may be very good at computer but not with its system. And in business, especially with dealing, if you're dealing with data, it's very required. With this required skill set, we could also conclude that somebody may be very good at mathematics, but they may not have a very good knowledge in business. And some people may be very well at technology in the sense of information technology, but they may not have good knowledge on the business knowledge or about business. So we need to have the combination of all of these three skills to be called a data scientists. Otherwise, the group of people, some people from mathematics department or mathematics area, some people from computer science, or some people from the domain knowledge will join force together, in order to form the pool of data scientists. They will have to cooperate because it's so impossible, right? I mean, the level of probability to have that one person with all this required skill set to be called a data scientist, it's quite promising. It is difficult to have one person who will have all these three set skills. That is why this is also the main reason why data analyst is becoming very difficult. And as what we have presented in the previous graph, the more difficult it is, the more valuable it will be. So imagine the worth of a data scientist nowadays. Going back to hacking skills, if the data is given, hacking is done. And we tend to look at it positively na lang so that, we will not have this notion that, okay, I will hack today because that's one of the skill set that I need to master in order to become a data or in order to be called a data scientist. Again, it is not enough that you're just a hacker. You need to have this set of skills. To further understand the difference between data analyst and data scientist, we also have this illustration. So the role of data scientist is bigger, because he or she needs to have the knowledge of advanced algorithms and machine learning and be able to come up with a data product, which I told you already previously. So the data scientist can come out with a data product. For example, the role of your data analyst is seeing it in your business context. He or may have the knowledge of business domain, the entirety of the business. He or she is so good in it. He is so good in doing analytics, like in the area of marketing. So he could be called a marketing analyst. Now, what is the difference between data analyst and data scientist? What kind of role they're doing? Basically, from that, we could say that if he is an analyst, we call it data analyst. If he's so good in doing analytics in the area of finance, then we call him a financial analyst. Now, what is Python and why Python? Little did we know, actually I just discovered this also as I studied my report, that there is actually a freeware and an open source. We call it Python. These are the features. It is a software, guys, with open source that is very simple and easy to learn. So it is for data analytics, especially for big data analytics. It is interpreted, dynamically typed, extensible, embedded, extensive. It has extensive library as well. So it is an encrypting. Python is a scripting language. The programs are fed into Python's interpreter, which runs them directly. So there's no compiling, which is the case for some other language programming. It is faster and easier to get feedback if we have got this Python code. Python means you complete and execute or run your program faster. And that makes programming fun. Again, it is a programming language. And it is written by a person called Guido van Rossum in the 1990s. So I hope you could be able to search this classmates in the Google or find tutorials in YouTube. It's very helpful. So what are the companies that are using this Python? So we have here Google, the NASA. Wow. Of course, because they've got, speaking of the volume of data, NASA, the Facebook, the Yahoo, the eBay, the YouTube, Dropbox, they are now using Python and we're not even aware that it exists. In games, I have also made further research about it, and in games, Activision uses Python for building games, testing, and analyzing stuff. They even use Python to find people cheating by boasting each other in internet search. That's what I've told you. a while ago, Google used Python all over in its early development phase. Even in our OS, no? In our operating system, in our laptops and computers, like Linux and Mac OS X, they use Python for some of their administrative functions. In particle physics lab, Python helps understand the data analysis from some atom smashing experiments at a specific lab. In space, like what I've told you, the NASA, the International Space Station's Robonaut 2 robot uses Python for its central command system. And it is even planned for use, this Python, in a European mission to Mars in 2020, this year, to collect soil samples. So imagine the use of Python. In what other fields this could be of great use? We have in astronomy, like the Meerkat Radio Telescope array, no? So meaning this could be used if we've got complex systems and volume operations, like those companies that you have mentioned. And even Spotify, no? Spotify music streaming service, and they use Python to send you music. Then we also have in the video industry, Netflix. They use Python to make sure movies play on stream without stopping. Python is used a lot also for YouTube. In movie studios, Industrial Light and Magic, like the Star Wars Genesis, they use Python to automate its movie production processes. So imagine how helpful Python is. The point here is that Python will apply to whatever you are interested in, no matter what it is. So maybe we could now start using it, benefit from it, because everyone else, especially big companies, they're benefiting from it. Let's try to go outside our comfort zone by using this type of analytics. Actually, if you're dealing with big data, talking about that, what is big data? So we have here the information from multiple internal and external sources, like transactions in our social media, the one that we have mentioned a while ago, like Facebook, Instagram, Viber, enterprise content, sensors, and other mobile devices. So these are the main sources of big data. Companies leverage data to adopt products and services. Why? To first, meet consumer needs or customer needs, optimize operations, optimize infrastructure, find new sources of revenue. And it could also reveal more patterns and anomalies through big data. In education, big data means personalized education. Measuring student learning using data analytics is less than a decade old, but has the potential. It still has its potential to transform education away from a one-size-fits-all model. Adaptive learning is a system that leverages data capabilities to deliver a training course that is personalized to the individual. With tutoring provided digitally, it continually gathers information on a student's performance in order to tailor their educational content. So that is the most important one, to personalize the data that a student could get online, having that educational content that meets their needs and interests, thanks to big data. Now let's proceed to the types of data or the levels of data measurement. When collecting or gathering data, we collect from individual cases on a particular variables. A variable is a unit of data collection whose value can vary. Variables can be defined into types according to the level of mathematical scaling that can be carried out on the data. So what are these 4 types of data or levels of measurement? We keep on hearing them actually. From time to time, from our basic statistics, we have heard them already. Now, I believe this is just a review for all of us because this is the basic of statistics. First, we have the categorical or nominal data. Then we also have the ordinal. Third is the interval. And fourth is the ratio. Going back to the level of mathematical scaling. So the level of mathematical precision with which the values of a variable can be expressed is what we are being referred to as the level of mathematical scaling. Research in the scientific sense involves the systematic measurement of these observations. When thinking about research, we are looking at gathering data, or we are looking at gathering knowledge through some form of observation. So when we collect or gather data, we collect information. And when we collect information, to analyze them better, we need first to identify what types of data we have gathered, because the type of measures that we could use for this data depends also on those or what the type of data we have gathered. Now we have here data for business analytics, example of classifying data elements in a purchasing database. Say for example, you have a business, no? And using Excel, you have now a summary of the purchase orders made for a specific month. So in the first column, we have the suppliers, order number, the item number, item description, item cost, quantity, the cost per order, the terms in months, and we have here the order date and the arrival date. Now, how could we apply data analytics here? By first identifying the types of data, which could be the nominal here, the ordinal, the ratio, or the interval. Do you have now your guesses? Let us reveal the answer. So in this figure, as we could see, the suppliers, the kind of suppliers fall into the category of nominal or categorical data, as well as the order number and the item number, the item description. These are all nominal. Then we have here ratio for the item cost, its quantity, the cost per order, and the terms. Then we have two intervals, two types of interval data, the order date and the arrival date. How did we arrive at this conclusion? Let us discuss these types of data one by one. First type is categorical or nominal data. Nominal or categorical data is data that comprises of categories that cannot be ranked or ordered. Each category is just different. So, meaning nominal data reflect qualitative differences rather than quantitative ones. What does this mean? No mathematical operations can be performed on this data relative to each other. So the categories available cannot be placed in any order. No judgment can be made about the relative size or distance from one category to another. Categories bear the quantitative relationships to one another. Example, the customer's location. You cannot order America from Europe, from Asia, no? From Antarctica. Another example I'll give you. Classifying residents according to zip codes. It is still a nominal data, even though numbers are assigned to zip codes, no? Like 8427, 8400. There is no meaningful order or ranking in these particular numbers. Did you understand? Another, the cars in a parking lot. They can be classified according to their colors, like green, red, silver cars, and a lot more. But no ranking or order can be imposed on the variable color. You cannot say green is superior than red. Systems for measuring nominal data must ensure that each category is mutually exclusive, and the system of measurement needs to be exhaustive. Exhaustive meaning the system of categories should have enough categories for all the observation. When you say mutually exclusive, each observation, person, or case of inertia, or score cannot fall into more than one category. Hindi siya pwede into categories. Dapat isa lang. Variables that have only two responses, like yes or no, not else. True or false, these are known as dichotomies. We have here another example. This is very common in a survey, right? Like, what is your gender? Please tick or please check. Male kaya or female? Or did you enjoy the film? Please check. Yes kaya or no? Next is ordinal data. Ordinal data is data that comprises of categories that can be ranked or ordered. Similarly, with nominal data, the distance between each category cannot be calculated, but the categories can be ranked above or below each other. So here, ordinal data works with the same assumptions as nominal data, but is more complex. In that here, while it's still comprising of categories. Comprising of categories, meaning, what does this mean? We can make statistical judgments about the relative position of one value to another and can perform limited mathematical calculations. A very good example of this is the college football rankings or the survey responses like poor, average, good, very good, excellent. Example, like in a survey, how satisfied are you with the level of service you have received? You just have to check very satisfied, somewhat satisfied, neutral, somewhat dissatisfied, or very dissatisfied. That is ordinal data. Another t-shirt is an example of the ordinal level of measurement. Are you aware of that? Let's proceed to interval and ratio data. Both interval and ratio data are examples of scale data. Scale data meaning the data is in numeric format like $50, $100, 150 pesos, 200 pesos, and data can be measured in a continuous scale. The distance between each can be observed and as a result, measured. And most of all, the data can be placed in rank or order. Let's discuss it further. Interval data. Ordinal data but with constant differences between observations. The ratios here are not meaningful. We have to remember that. Example, the time. It moves along a continuous measure seconds, right? In minutes and so on. And is without a 0 point of time. Did you understand? And so with temperature, it moves along a continuous measure of degrees and is without a true zero. Another example, I'll give you IQ, or intelligent quotient. It is an interval data or interval level of measurement. Why? There is a meaningful difference of 1 point between an IQ score of 109 and an IQ score of 110. But there is no meaningful zero to this scale as IQ tests do not measure people who have no intelligence. You see, temperature and truth zero, as also what I have mentioned a while ago. Like this, frog. Temperature of a jumping frog is another example. There is a meaningful difference of 1 degrees Fahrenheit between a temperature of 98.6 degrees Fahrenheit and 99.6 degrees Fahrenheit. A meaningful difference, right? If you're gonna subtract, you will have 1 degree Fahrenheit. But 0 degree Fahrenheit does not imply that the frog has no temperature, right? You could not say, wala siyang temperatura dahil 0. Same with the condition or examples presented a while ago. We could not say walang oras because it's 0. We could not tell. Now we have ratio data. Ratio data is measured on a continuous scale and does not have a natural 0 point. Ratios are meaningful, unlike interval. Examples are monthly sales, delivery times, the weight, the height, or age. These are ratio data. Another example, if one person has 200 Instagram followers and another person has 100 followers, then not only is there an interval difference of how many? Right, 100 followers, but we can also state the relationship between them as a ratio of 2:1, since that is 200:100. Stated another way, the first person has twice as many followers as the second person. There is also a meaningful 0, unlike kanina, because if the value of one variable is 0, it implies that person has no Instagram followers. The ratio level of measurement possesses all the characteristics of interval measurement. Have you noticed that? And there exists a true 0. Unlike kanina with interval data. In addition, true ratios exist when the same variable is measured on 2 different members of the population. Now I have here a set of examples, and I want you to help me identify or classify each of these according to the level of measurement. Number 1, we have points scored by basketball players in the game. Number 2, time of day. 3, the birth city for a sample of students. And the 4th is the level of agreement on the survey. I'll give you enough time. You've got 5 seconds. You can write your answer in any paper and we will reveal the answers later. Are you done? Now let's reveal the answers. For number 1, points scored by basketball players in the game. Let us identify its characteristics individually. Can the data values be ordered? Yes. 10 points is less than 20 points. Another, interval differences exist between the data values, right? 20 points minus 10 points equals 10 points. True ratio exist? Yes, true ratios exist between the data values. 20 points over 10 points, that is 2:1 ratio. There exists a significant 0. 0 points implies that a player did not score. If we have these characteristics, what kind of data is this? Taran! It is a ratio level of measurement. Very good. Number 2, time of day. The data values can be ordered. 2:30 comes before 5, right? And 30 comes before 6:30. Interval differences exist between the data values. There is a measurable span of 2.4. There is a measurable span of 2.5 hours between 2:30 and 5. Now, true ratios do not exist between the data values. It cannot be stated that 5 is twice as late as 2:30. We could not say that. So, there does not exist a true 0. If someone requested the time, you could not say, if someone asks you what time is it, you could not say 0. If we have these characteristics, then what kind of data is this? Ta-da! That is interval level of measurement. Very good. Let's proceed to the third example. Birth city for a sample of students. No ranking order can be placed in the data. Do you agree? Yes. We cannot say that Makati City is better than Surigao City. There is no definite criteria for that. Meaning, this type of data is nominal level. Very good. Last, the level of agreement in a survey. Can we order them? Yes, data can be ranked in order, like strongly agree, disagree, neutral, agree. What else? No interval difference can be measured between the data values. So, meaning this type of data is ordinal level of measurement. So, that's all for my report. Thank you for listening. I hope you have learned something today. Again, I'm your discussant, Roxanne May Garfield.